In this module, I'm going to cover the cloud deployment models, and I can fit it all into one lesson.
This video is brought to you by Appy's Academy.
The NIST defined 4 cloud deployment models. That's public cloud, private cloud, community cloud, and hybrid cloud. And we'll cover each of those different deployment models in this lesson. Starting off with public cloud, the way that NIST defined that. The cloud infrastructure is provisioned for open use by the general public. It may be owned, managed, and operated by a business, academic, or government organization, or some combination of them. It exists on the premises of the cloud provider. Examples of public cloud are really all the well-known cloud providers that you know about, like Amazon Web Services, Microsoft Azure, a couple of examples there of IaaS and PaaS. IBM Bluemix is a PaaS example, and Salesforce is an SaaS example. So all of those are cloud providers which sell their services to the general population. And public cloud is by far the most common deployment model. Next up, we have private cloud. The way that the NIST defined that, the cloud infrastructure is provisioned for exclusive use by a single organization comprising multiple consumers, for example, business units. It may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premises. Private cloud works the same way as public cloud, but the services are not provided to external public enterprises like they are with public cloud. They are provided to the organization's own internal business units. So there can be a bit of confusion about how is private cloud different than on-premises then, if it's just operated for a single company. Well, the difference is that private cloud fulfills the cloud essential characteristics that we spoke about earlier. So those characteristics are on-demand self-service, rapid elasticity, broad network access, resource pooling, and measured service. Private cloud will fulfill all of those characteristics, whereas an on-premises solution does not. The most obvious example of that is with a traditional on-premises model. A business unit orders a new server by raising a ticket with the IT department. The server is then provisioned and configured by the server, network, and storage teams as separate manual processes. With private cloud, however, a business unit orders a new server typically through a web portal. The server is then automatically provisioned without requiring any manual intervention. So if you remember the lesson we covered earlier about on-demand self-service, and I showed you about how we could provision a virtual server in AWS, we went to the web portal, I configured all the settings that I wanted for my virtual machine, and then in the background, automation software deployed everything automatically, and the virtual machine was up and running in 15 minutes. That's different than would happen with a traditional on-premises model where everything would be done manually, and typically it would take a week or more to get the server up and running. So with private cloud, it's different than on-premise in that we've got all of those characteristics. So just like with public cloud, when the business unit provisions a virtual machine, it's all going to be done in the back end automatically. That's going to be using automation software like BMC, CA Technologies, or Cisco UCS Director. Now, there's a lot of other automation software available, and also if the company's big enough, they might even end up developing it themselves. Private cloud is most suitable for large companies where the long-term ROI and efficiency gains that they'll get from the solution can outweigh the initial effort and cost to set up the infrastructure and automated workflows. Private cloud is an expensive solution because the data center is dedicated just for that one customer, and all of the infrastructure in there as well, again, is just for the one customer. So it's going to be very expensive to get the data center set up. Also, for everything to be automated, this all needs to be set up ahead of time as well. So that automation software will need to be deployed, and all of the workflows will need to be written, and all of the integration between the front end and the back end components, such as the storage, the networking, and the server, will all need to be developed and tested as well. So it's expensive and time consuming for private clouds to get up and running. But if the company is big enough, they can make long-term cost savings from doing this. There aren't many well-known examples of private cloud because companies with private cloud don't usually advertise the fact because it's, well, private. However, a well-known example is US Department of Defense on private cloud, which is provided by AWS. That's an example of private cloud owned, managed, and operated by a third party rather than the company who's using it themselves. I also want to give you some information on something that's sometimes called private cloud but isn't really here as well. Public cloud IaaS providers will sometimes market dedicated servers as private cloud because the underlying servers are dedicated for a particular customer. But it's not true private cloud because it's only the servers that are dedicated for the particular customer. The supporting network infrastructure like the switches, the routers, the firewalls, etc. is shared. So this is not true private cloud. For true private cloud, the entire solution is dedicated for the particular customer, not just the servers. The next deployment model is community cloud. NIST define this. The cloud infrastructure is provisioned for exclusive use by a specific community of consumers from organizations that have shared concerns. For example, mission, security requirements, policy, and compliance considerations. It may be owned, managed, and operated by one or more of the organizations in the community, a third party, or some combination of them, and it may exist on or off premises. So community cloud is similar to a traditional extranet. To give you an example of that, I worked for an oil and gas company before, and we had private network connectivity with other oil and gas companies such as BP and Shell so that we could share information with each other. But community cloud is a little bit different than that in that it's full shared data center services instead of just network connectivity between on-premise offices. Community cloud is the least common deployment model. The final model we have is hybrid cloud. This is defined by NIST. The cloud infrastructure is a composition of two or more distinct cloud infrastructures, private, community, or public, that remain unique entities but are bound together by standardized or proprietary technology that enables data and application portability. For example, cloud bursting for load balancing between clouds. Let's have a look at this in a little bit more detail. So you saw the term there, cloud bursting, what this is about. Companies with limited private cloud infrastructure may cloud burst into public cloud for additional capacity when required. So maybe I've got my own private cloud infrastructure at my company and my data center, but I've got limited capacity there. I've only got so many servers. Now, a way that I could scale is by growing my own private cloud, but I would have to pay for the hardware for that, which would be expensive. A way that I can make it more cost effective is if I'm running out of capacity on my private cloud, then I can expand into a public cloud. A company could also have private cloud at their main site and use public cloud for their disaster recovery solution. That's quite common as well, because building the private cloud infrastructure like we talked about already is expensive. If we wanted to double that for a disaster recovery site as well, that's going to take the cost even higher. We could bring the cost down by having the main data center as private cloud and then use public cloud for our disaster recovery site.